Module 8, Lesson 5 covers slope-intercept form. This is one of the big concepts that you're going to learn in math this year, and you're going to carry on with you into algebra and algebra 2 and calculus and all those other things. Slope-intercept form, this is a biggie. This is something you really need to pay attention to. The pacing guide claims this is going to be a 90-minute long lesson, so they're saying about 2 days. We'll see how that ends up going. The National Mall in Washington, D.C. receives millions of visitors each year. It is home to the Washington Monument, the Lincoln Memorial, the Vietnam Veterans Memorial, and many other landmarks. There are many sightseeing tours you can take to learn about the city's attractions. If you haven't been there, it's really worth going to. Suppose a sightseeing tour company charges $7.50 for each hour you rent a motorized scooter, plus a non-refundable fee of $45. How can you determine the total cost for renting the scooter in relation to the number of hours that you have ridden on it? These are the kind of things we're going to be learning about in today's lesson. Non-proportional linear relationships can be written in the form y is equal to mx plus b. And that form, y equals mx plus b, is known as the slope-intercept form. It's also known as the y-intercept form. You can see right here, you've got your slope. That's going to be your m value. And you're going to discover your slope just like we've done all the other slopes we worked. And then your b, that is going to be your y-intercept. And the y-intercept is the point where the graph crosses that y-axis. Now we're going to look at that a little bit further, so don't be stressed if you're not quite understanding all of this yet. Now you can see here the textbook tells us that when an equation is written in this form, the m is going to be your slope, so we'll go ahead and highlight that, and the b is going to be your y-intercept. I'm going to highlight that. And we'll also note your y-intercept is going to be the y-coordinate of the point where the line graph crosses the y-axis. So that's going to be a definition, and this here is going to be a definition too, so we're going to highlight those in green. Scrolling down, your equation, y is equal to 1/2 times x plus 1. That's an example of a line or a graph or equation that is written in slope-intercept form, and you can see right here on the graph your slope has a rise of 1 for a run of 2, so your slope is 1/2 rise over run, and your y-intercept is this spot right here. It's going to be 1. You see you got a 1 right here in your equation, and that crosses the y-axis where y's value is equal to 1. So anytime you've got an equation written in slope-intercept form, all you have to do is start where your y-intercept is and then do the slope. Rise 1, run 2. Rise 1, run 2. Connect the dots, and graphing it is really that simple. Now I should point out that they keep talking about this being a non-proportional line. But it's non-proportional because the graph does not go through the origin. Remember, if it is a straight line graph and it goes through the origin, then it's going to be a proportional relationship. But if it does not go through the origin, even though it's a straight line graph, now we know it's going to be non-proportional. In a non-proportional linear relationship, the graph passes through point 0b, which is going to be your y-intercept. So this point right here, you can see they have labeled as point 0b, where x is 0, y is equal to, whatever y is equal to, they're calling it b. That's going to be your y-intercept, and you can use the slope formula to derive the equation of a line in slope form. So from there, what are they going to do? They're going to find the slope of the line. To find the slope, they took and wrote it as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, and they know that one of those points they're going to have is going to be this point right here, point 0b. So they let y sub 1 be point b. Let's zoom in just a little for you here, and let x sub 1 be point 0. From there, they're going to pick another. They're going to acknowledge that if you were to take and say that, well, x minus 0, that's just going to end up equaling x. And that's the reason the equation changed from here, from the x minus 0 to just x. Next thing they're going to say to us is that, well, from there, we could take and isolate the variable x, well, excuse me, isolate the y minus b by multiplying x on both sides. They didn't show it to you, but that's what they're doing right here. If they multiplied x on the left and they multiplied x on the right, the x's on the left would divide each other out, leaving your y minus b. And on the right-hand side, now you get m times x. Last thing we're going to end up doing to derive this formula is we're going to take that minus b and we're going to add b to both sides. When you do that, the b's on the left zero out and you get that formula, y is equal to mx plus b. So that is an example of how you derive the formula for solving these. Once again, don't be overly stressed if you get a little confused on that. I'm not nearly as interested in you being able to derive the formulas as I am interested in you being able to use them. Now, for example 1, they want us to identify the slope and the y-intercept. It's really going to be super simple. Your slope is right there, 2/3. Your y-intercept, -4. That's all there is to doing this, guys. I mean, it really is that simple. So they took and have listed, write the equation in the form y equals mx plus b, which it already is. Your m value is going to be your slope. Your b value is going to be your y-intercept. Now, I will point out that they made the pretty problem ugly, where we had x minus 4. They did x plus a -4 because that puts you in that mx plus b format. So the slope of that line is going to be what? It's going to be 2/3. Accept that one. And then the y-intercept, what's that going to be? It's going to be a -4. Accept that, and boom. It really is that simple to work these problems of identifying your slope and your y-intercept. Now it's going to be your turn. Pause the video for just a few seconds and find your slope and your y-intercept. How'd it go? Well, your slope, that's this value right here, -5. Your y-intercept is your b value, which is a +3. Come down here and check it, and it checks. I told you this stuff was easy. It really, really is. Now, for example 2, they're giving us the formula, once again, for slope-intercept of y is equal to mx plus b, and they want you to write an equation of the line in slope-intercept form, where your slope is -3, and your y-intercept, that's going to be -4. Piece of cake. So you can see right here where they have the slope m, they put in the -3 because it says right there your slope is -3. Where they had a b value right here, a plus b, they ended up making that plus a -4 because the y-intercept's a -4. And then finally from there, they made the ugly problem pretty by multiplying the signs, which gave them -3x minus 4. That is what you're going to end up putting right here, -3x minus 4. That would be your equation in simplest terms. Super easy. Now you pause the video and do this one here on your own. How did it go? For me, the slope is going to be 3/4. Your y-intercept is going to be 2. So my equation of the line is y is going to equal to, get my fraction in there, 3/4 times x. And that's going to be a +2 plus 2. Accept it and check it. The problem checks. Easy math. Now, what if we had a graph and we wanted to be able to take and write the equation in slope-intercept form based off of the graph? That's not hard to do either. So we're going to do this, we're going to take and start off by finding the location where the line crosses the y-axis. That's also known as the y-intercept. And for this graph, it's going to be right here at -1. The next step we're going to do is find the ratio of rise over run. So I'm going to pick any 2 points. I got a solid point here and a solid point here. So that means I'm going to rise 1, 2, 3, and I'm going to run 2, 1, 2. So my slope is going to be 3/2. and then substitute in the values for slope m and y-intercept b into the equation y equals mx plus b. Now, if you take a look, let's zoom down just a little bit, you can see right there, they showed us the y-intercept is at -1. They showed us the slope. They chose these 2 points, but they still rose 3 and run 2, giving you a slope of 3/2 that you see in the image here. And then finally, the final equation, y is equal to 3/2 x minus 1, because minus 1 was going to be your y-intercept. Super easy. Now it's your turn. Pause the video, work out this one on your own. Go. How'd it go? First thing I want to do is I want to take and acknowledge that my y-intercept is right here, and that's going to be a -4. Let me go ahead and take a screenshot of this so we can actually kind of draw it out on paper and show you exactly what my thought process is. So I'm going to take and get ourselves some open real estate, and nope, didn't copy right. Hold on, we're almost there. Copy that thing and paste it right here. And from here we can take and see that we have a y-intercept, which is going to be right there. Now that means the y-intercept's value is going to end up being a -2, so that we can take, and of course you would put an ordered pair is 0, -2. So the y, excuse me, or not y, our b value, because b is what we use to represent our y-intercept, our b value is going to equal to a -2, and then our slope is going to be rise divided by run. So I'm going to go from this point to that point. I'm going to rise 1, 2, 3, 4, 5. So that's going to give me 5 divided by 1, 2, 3. So my slope is going to be 5/3, and that will give me the equation y is equal to, of course we had mx plus b as our formula, so our slope is going to be 5/3, we leave it as an improper fractions, times x plus our -2 for our y-intercept, which simplifies down to y is equal to 5/3 x minus 2 for our final answer for that. I'm going to jump back over to our textbook page. Y is equal to, we ended up getting a fraction of 5/3 times x minus 2. Check our answer, and it checks. This is where we're going to stop part 1 of this video. Come back and watch part 2 so we can learn a little bit more challenging stuff that we need to know when it comes to working with slope intercept.